Today I'm going to discuss the topic of code coverage, specifically the MCDC code coverage, which is an acronym for the Modified Condition Decision Coverage. It is the type of code coverage required by the safety critical applications in the avionics industry. That means the softwares that are running inside airplanes. I am going to use and be facilitated with my discussion using the PowerSoft C++ Test Professional. It is a product by PowerSoft that provides static analysis, unit testing, and code coverage analysis for C and C++ code bases aimed at helping organizations improve code quality and ensure compliance with coding standards such as Mesra, AutoSAR, CERT, OWASP, and many others. Now, this discussion is going to pivot around this function that we have here. It returns a Boolean and accepts three parameters A, B, and C. And I will also be using a special feature of the PowerSoft C++ test, which will be used to parameterize the possible many inputs of A, B, and C coming from a table. So this unit test here, you can see that the values A, B, and C are coming from the data source here, and that data source looks like this. Since this data source only contains two rows in this particular unit test, the unit test will be invoked twice, once for every row and giving these values of A, B, and C accordingly. And from the column D, we see that it either returns false or true. Therefore, we can see that running this particular unit test here should give us a 100% line coverage. Let us run this particular unit test now. From the coloring syntax here, indeed, we can visually see that we have a 100% line coverage. The exact percentage is also reflected in this coverage tab here, but the more complete measurements of different types of coverages are in this tab here. We can see it has 100% line coverage, but by MCDC standard, we only have 33%. What is then MCDC code coverage? And how is it that a unit test which has 100% line coverage only has 33% MCDC coverage? Let us begin to dissect this function now. The parameter of this function A, B, and C has a say and influence that controls the behavior whether this function returns true or false. But because the values of A, B, and C are only a subset of the exhaustive complete 8 total combinations, which is 2 to the 3, the two rows from this parameterization table means that we excluded the other possible values that can go into A, B, and C, and this explains why that by MCDC standard, this particular unit test is incomplete. And therefore, if we have a parameterization table that contains an exhaustive possible values of A, B, and C, we can claim 100% MCDC coverage. Let us look at this particular table here, having the exhaustive complete possible values of A, B, and C, and run this associated unit test. And just as before, we have 100% line coverage, but because our table is the complete possible combinations of A, B, and C, we also have 100% MCDC coverage. There is a subsumption principle here. If you have a 100% MCDC coverage, automatically implies that you also have 100% line coverage, but not the other way around. So we can see now that the MCDC coverage is a stronger type of code coverage standard. But the discussion is not quite complete yet. Suppose that we have a subset of the possible 8, which we have here instead 6. And if we use this parameterization input and run this unit test, we have 67% code coverage, which makes sense because of the subset parameterization values we have here. Whereas the MCDC requires an exhaustive 8 possible combinations to complete, there is actually a relevant subset of the total 8, which is a much lesser number of possible inputs, yet can give us a complete 100% MCDC coverage. And the formula given here is instead of 2 to the n, the minimum number of inputs is actually n plus 1. With n being 3 here, that means that this carefully prepared 4 rows here can give us 100% MCDC. Now this reduction of inputs from the exhaustive 8 to relevant 4, yet giving us 100% MCDC, comes in handy when the function under test takes time to complete, because now with fewer runs of the unit test completes faster, yet claiming the same 100% MCDC coverage. Let us run this particular unit test now with these 4 subset. And despite it has 4 rows, but because they are relevant inputs, carefully prepared, we still have 100% MCDC code coverage. Not all tools can do this measurement. The Parsop C++ test has specifically very strong support for MCDC measurement. And that completes the topic on MCDC. And I'm going to discuss another topic still related to code coverage, and that is the feature of this tool to collect separate coverages of two runs of a unit test. So we have this unit test here for rows and return, causing the function to return false, and another unit test here causing the function to return true. So if we run this unit test here, it will only give us an incomplete code coverage as indicated by this graph here. There is a missed regions of the code. But then we can continue to run the second unit test here, which has a different set of parameterized input, and running this on top of the previous run will combine the two code coverages, thereby completing 100% line coverage as a result. You can see here everything is green. So we have seen now how the PowerSoft C++ test can clearly measure MCDC code coverage as well as uh, collect code coverages across several runs of the unit test, and through the feature of parameterized input, a single unit test can behave as if it is multiple unit tests because the data that is used to call into the function will be coming from a table such as this one.